Hello everybody, Namaste. Welcome back to my YouTube channel. My name is Anushka and I'm studying in Sri Venkateshwara College of Engineering. Today we'll be looking at normal distribution. Let's understand what normal distribution is. The normal distribution, also known as the Gaussian distribution, is a probability distribution that is symmetric and bell-shaped. Symmetric means when a graph is divided into two, both the halves are equal. And bell-shaped is basically the inverted U shape. It is characterized by its mean. Mean is basically the sum of all the terms divided by the number of terms, and standard deviation is the deviation from the mean. And it is a key concept in statistics and data analytics, frequently appearing in natural phenomena and social science. Let's understand the characteristics of a normal distribution. Symmetrical. A normal distribution is symmetrical with mean, median, and mode being equal. Bell-shaped curve. The graph of this normal distribution forms a bell curve. We have a rule known as 68, 95, 99.7 rule, which states that around 68% of the total data falls within the 1 standard deviation, 95% falls within the 2, and 99.7 within the 3. Let's understand the different types of bell curves. Number one is statistical distribution. Now let's understand what it is. The bell curve, also known as the Gaussian distribution, is a commonly statistical distribution that is symmetrical and bell-shaped. There is another bell curve that we can observe, that is the mean and standard deviation curve. It is characterized by its mean and standard deviation, allowing for analysis of data variability and central tendency. We have application in data analytics, which is one of the most emerging topics, as to analyze the data is the requirement of the new generation because it generates hundreds and thousands of data per second. Application in data analytics. The bell curve is widely used in data analysis, representing natural occurrence and behavior of many variables. Standard deviation and mean in a normal distribution. Let's understand this. The standard deviation in a normal distribution represents the spread of the data around the mean. A larger standard deviation indicates that the data points are more spread out from the mean. That means there is more divergence. The mean or average, in other words, is the central point around which the data is distributed in the normal distribution. We have a formula y equals to 1 by sigma root 2 pi the power e minus x minus nu square by 2 sigma square. Let's understand what these terms are. Here, nu is the mean and sigma is the standard deviation. Another point to note is that square of standard deviation will be equal to the variance. Pi, as we know, has a standard value of 3.14159 and so on, as it's an irrational number. E equals to 2.718828, and it goes on. Let's understand the z-scores and the standard normal distribution. Understanding the z-scores. Z-scores measure the number of standard deviation a data point is from the mean. So basically, it is the measure, the number of standard deviation. If we take a data point and we measure the number of standard deviation from the data point to the mean, we can understand the z-score. Interpreting the z-score. A positive z-score indicates a data point above the mean, while a negative z-score represents a data point below the mean. Application of the standard normal deviation or distribution. The standard normal distribution has a mean of 0 and standard deviation of 1, making it useful in comparing different data sets, as these numbers are pretty useful. Let's understand the empirical rule and percentages within a normal distribution. 68, 95, and 99.7 rule states that the approximate data, out of the data, 68% falls within 1 standard deviation, 95 within the 2, and 99.7 within the 3. The mean and standard deviation Determine the percentages within a normal distribution according to the empirical rule. Empirical rule application used to estimate percentages or probabilities within a normal distribution, aiding to data analysis and decision making, both of which are very important in today's life. Application of normal distribution in statistics. Let's look into the applications of normal distribution after discussing what normal distribution. And first is quality control. Let's understand. Normal distribution is used to analyze a product variation and ensure consistency in manufacturing processes. So quality is basically how sturdy, how good the product is. It is to know the qualities, the characteristics of a product, and we can do it by normal distribution analysis. It helps in setting quality standards and identifying defects within acceptable limits. All of this can be used in different industries in order to make sure that the product that they're manufacturing is of the best quality to be served to us as consumers. And it is easier if you use the normal distribution to identify the defects. And if you identify the defects sooner, the cost will be less to correct it or perhaps to later on recover it. Finance and economics. In financial markets like stock market, which is the talk of the town, as stocks have become the new, and we have heard of bitcoins, and there are other financial stocks and other financial elements which have come into the market, or perhaps they were already existing but have become more popular. In financial markets, like stock prices and returns, often follow a normal distribution. It is used to make a model and analyze various economical variables and investigate strategies, which can be also used to determine the economics of a city or perhaps a state or perhaps a locality and get a graph of biological phenomena. It is applied to understand biological traits like height, weight, and blood pressure in a population. A graph is basically a pictorial representation of the data, which makes the understanding procedure much easier. Health science researchers use it to study human status characteristics. Other biological phenomena is basically nature loves symmetry, and you will always see a symmetry around you. Let's discuss about the central limit theorem and distribution and normal distribution. Central limit theorem states that the sampling distribution of the sample mean approaches a normal distribution, which is the statement of a central limit theorem, that the sampling distribution, basically you take a sample and you calculate this distribution of the sample mean always approaches a normal distribution. Mean and standard deviation, these are the key parameters in determining the shape of a normal distribution. Characteristics, symmetrical bell shaped, as I mentioned before, with specific properties. The central limit theorem plays a very crucial role in statistics as it allows for the assumption of normal distribution even when the underlying data is not normally distributed. The mean and standard deviations are fundamental properties that define the shape and behavior of the normal distribution curve, which exhibits symmetrical characteristics. Let's look into the limitation and assumptions of normal distribution. Limitation is not suitable for data with outliners of heavy tail distribution. Assumptions are assumes data is symmetrical with a single peak and it follows a bell curve, where it is applicability may not apply to real world phenomena, especially in social science. Thank you so much. I hope you have learned something from it. And until then, I'll see you in the next one. Keep learning. Thank you.